This video is Introduction to Propositional Logic. It's Chapter 2 from our book. Getting right into it. Propositions and their interrelationships. A proposition, roughly speaking, is a condition of the world that can be either true or false, but not both simultaneously. So we take a binary look at the world. I'm going to give some examples because in my experience, just saying something like this is really abstract and students have a hard time with it, so they need some examples. So we're going to create some simple logic sentences from English sentences. Sometimes we call a simple logic sentence a proposition constant, and sometimes we call it a logic constant. I might use those terms interchangeably. So let's look at a simple example. The animal eats fish. That's an English sentence. In the construct of our of the way that we build logic sentences or proposition constants, we'll always use lowercase letters to start them off. So here's an example of how you might translate that. By the way, FYI, this simple logic sentence can have a truth value of either true or false. It helps students to think of things that they already know. So for example, if I were to say, the animal eats fish, if we are thinking of an example of an animal, like for example, a bear, we might say that's a true sentence. So the truth value for a bear is true. But for example, if it is a rattlesnake, then we would say the truth value of that sentence is false. So a logic sentence can have a value of true or false. Okay. Again, it is raining. Simple English. It is raining. Today is Saturday. Today is Saturday. Rabbits prey on wolves. Rabbits prey on wolves. You get the idea. I will often revert to just using the English language sentences as my proposition constants. But in your mind, think of them like this so that we can meet the convention of naming proposition constants using lowercase letters and a string of characters. All right. A warning here, though, kind of a big one, is students think that if a sentence cannot be a proposition, they think that if it's false in their experience, then it can't be a proposition. So saying rabbits prey on wolves, in their minds they're thinking, that's not true, which means to them that can't be a proposition. But remember, propositions can be true or false. By the way, logic doesn't necessarily have to connect to the natural world that we know. So you might imagine, like the crazy rabbit planet, where rabbits have evolved into massive canine-like predators that prey on wolves. Of course, that world doesn't exist on our planet, but it could, hypothetically. So again, I think the warning here is that students get caught up in thinking that propositions have to be true as they understand the world. And that's just not the case. And also, I think we'll find that there's a lot of cases where the way they think they understand the world is not necessarily the way the world actually is. That's true for all of us. Okay, so that's a warning. There are 5 kinds of compound sentences in the structure that we'll be using. The first is negation. And so what does negation look like? Well, if we have a proposition constant P, it can be either true or false. If you remember, we said it's any statement that can be true or false. The negation of that is just literally making it the opposite. So if it was true, it became false, and if it was false, it became true. So the negation is true whenever the original sentence is false. That's simple. And it's false whenever the original sentence is true. Okay, I don't want to belabor it, but here's an example. It is raining. It is not raining. And by the way, the symbol that we use here, the tilde, can also be another symbol I'll show you later. This is a logical proposition, and that's the negation of that proposition. Simple enough. Okay. Now, here's another example. The animal is a carnivore. The animal is not a carnivore. Simple enough. Again, negation, one of the compound sentences. Another compound sentence is conjunction. And sometimes people call this the AND function. because we sometimes will say P and Q. This symbol right here, this caret symbol, means and. I'll sometimes use the ampersand to represent that as well. So this is sometimes called the and function by students or people in general, I suppose. So P and Q, what are we saying here? P and Q is only true if all the conjuncts are true. In this case, we have two conjuncts, but we could have any number n, any finite number n. And they would all have to be true for the conjunction to be true. Another way to think about this is the conjunction is false when any one or more of the conjuncts are false. So in either case, 2 or 3, only one of the conjuncts has to be false for the conjunction to be false, or if both conjuncts are false, then the conjunction is false. By the way, underneath each of these compound sentences, I'm writing sentences, English sentences. It's really valuable in my experience to have students sort of memorize those statements. So whenever they come to a conjunction, say, all right, a conjunction is only true when all the conjuncts are true. Literally saying that and having them write it helps a lot. Okay, so here's an example. It's raining. Today is Saturday. Those are two conjuncts. Today is a rainy Saturday. Remember, that sentence can be true or false. So I might say, in the pouring rain, standing in the pouring rain, I might say, today is a rainy Saturday, but the calendar I look at says it's Tuesday, so that sentence would be false. Also, I could be standing in a beautiful sunshiny day and say, looking at the calendar, notice it's Saturday and say today is a rainy Saturday, and that would be a false sentence. Remember, conjuncts can be true or false. Third kind of sentence, compound sentence, is a disjunction. This is sometimes called an or sentence or an or statement. And by the way, this vertical bar represents an or. I'll also use the upside down caret to represent that at times. Okay. This is the disjunction is true if one or more of the disjuncts are true. In our case, we have only two disjuncts, but it could be any finite number n. Let's see, the disjunction is only false when all the disjuncts are false. Remember, those statements that I'm writing at the bottom of these compound sentences, really important, I think, for students to kind of memorize those. You should have a resource in your classroom where you write those, because students will struggle with trying to evaluate a disjunction or a conjunction or an implication, and when they're struggling, draw their attention to the sentence that tells you how to evaluate that sentence. Okay. Here's an example. Two disjuncts. Today it is raining, or Saturday, or possibly both. By the way, we'll be using the convention that the or statement is an inclusive or. That means it can be one or the other or both to make it true. This disjunction, P or Q. Yay. Today is raining, or it is Saturday. And that could be true if it was raining on a Tuesday, or it could be true if it was sunny on a Saturday. It could also be true if it was raining on a Saturday. Okay. Implication. This is the one that gives students the most difficulty in my experience, and so I'll have a separate video on this one to help. But I just want to go over this rather quickly. So an implication, and I will use this one direction arrow like this to show implication, and we'll literally say P implies Q. By the way, when there's an implication, the part that comes before the arrow is called the antecedent, and the part that comes after the arrow is called the consequent. So I'll use that terminology. The implication is only false. This is really important because it's hard, so easy for students to mess up evaluation of implications. So if this sentence is the one sentence that can help them the most. The implication is only false if the consequent is false while the antecedent is simultaneously true. Look at case 2 here. The consequent is false while the antecedent is true. That's the only case where it's false. Here we have the consequent is false, but the antecedent is false, so that's still a true the implication sentence is still true. This one is challenging, so I'll have a separate video on that one. The implication is true anytime the consequent is true. All right, so any case where the consequent is true, that's case 1 and case 3, doesn't matter what the antecedent is. Notice how the antecedent is true or false. So as long as the consequent is true, the antecedent can be true or false, doesn't matter. The implication is true anytime the antecedent is false. So if you look at the antecedent and see that it's false, that means where is P false? That's case 3 and 4. Notice that the implication is true both times. So those two sentences are really useful. The implication is true anytime the consequent is true, and the implication is true anytime the antecedent is false. There's actually 3 sentences here, really important sentences. So I've just found through experience that you've got to have those sentences somewhere in your classroom and give students access to them. All right. Here's an example of an implication, an antecedent and a consequent. It looks like this. If there is mass today, then it is Sunday. Some of your students might say, hold it, there's mass on Wednesday, or there's sometimes Friday mass, or whatever the case may be. So, okay, remember, this implication statement can be true or false. Just because I write the implication doesn't mean that it has to be true. That's something that kids will struggle with. They want the sentence to be true for it to be a logic sentence. Okay, here's the biconditional implication. This is, at first glance, more complex, but I would argue not any more complex than what we've already done. As long as you understand conjunction and implication, this is just a combination of the two. So remember what we said. I'm going to now break this down into 2 different implications. P implies Q, and the second implication will be Q implies P. Let me go back. Remember that we said that P implies Q would only be false if the consequent was false when the antecedent was true. That's case 2. That's where it's false. Every place else is true. Same thing is true for this guy. Q implies P is only false if the consequent is false when the antecedent is true. So here the consequent is false P when the antecedent is true Q in case 3. Same rule, but it's a different case because we switched the antecedent and the consequent. All right. Now if I make a conjunction statement, that is to say P implies Q and Q implies P, another way to think of that is think of the arrow going both ways. That's what the next column says. So that's only true when both are true, or both of the conjuncts. Remember, now we're talking about the conjunction. This now is a conjunction of 2 sentences. It's the and statement between those 2 sentences. So where are they both true? They're both true here in case 1, and they're both true here in case 4. But they are not both true in case 2 and 3. So we've got this as our truth statement, or as our truth assignments. Finally, we use a shorthand version. So this statement right here, P implies Q and Q implies P, shorthand is P biconditionally implies Q, or Q biconditionally implies P. Both are the same statement. Okay, now this one gets a little bit tricky, but not too tricky. Just some things that I've noticed. I mean, it's not like I originally noticed them, but help my students to notice this. The biconditional is only true if both directions of the implication are true. That's the conjunction of the implications. Okay, that's the simplest way to see it. But the biconditional is also only true if both sentences forming the biconditional have identical truth values. That is, if both are true or both are false. Now, there's no case here where they're both false, but you should try that with your class. Create a case where that exists. The biconditional is only false if the sentences forming the biconditional have opposite truth values. So here, in our case, false true or true false. That's the sentences that form the biconditional have opposite truth values. When that happens, the biconditional is false. Okay, here's an example. And this is different than the statement that we had before because it says there is mass today if and only if it is Sunday. Okay, the if and only if is often an indication of